Hello test takers, welcome back to Exam Prep Solutions, and today we're going to be going into finding the specific energy of a stream. In a previous video we went over finding the critical depth for a rectangular channel, but in this one we're going to go over finding the specific energy, which involves a lot of different facets of hydrology and hydraulics here. So let's get into the problem. Go ahead, try and solve this one without my solution. This is the reference material that I'm using, but you should have your FE reference manual open and making sure that you're checking what is in the reference manual and using that for your problems there. So let's get into this one. It says find the specific energy of a stream given the following characteristics. You get a width of water surface of 5 feet, a 25-foot squared area of the stream, and then assume that the kinetic energy factor is 1.0. So how are we going to solve this one? Well, here's the specific energy equation. It's E equals alpha. I'm just going to put that as A for now. V squared divided by 2G plus Y. Don't forget plus Y. Or it could also be alpha Q squared divided by 2G A squared, capital A for this one, plus Y. So that's the equation, but we do not have everything we need to use that equation directly. So we're going to use this critical depth equation here, Q squared over G equals A raised to the third divided by T. So we need to use that because we need to find the discharge, which was not given. So we can insert that into this specific energy equation here, so then we can get the final answer. So we're solving for Q in this case. So we have Q squared divided by G, that's 32.2 because we're using English units. A raised to the third. Well, 25 feet squared is the area of the stream, so we're going to go with 25, and that's going to be raised to the third power. That's all divided by T. And T, just given the width of water surface equals 5 feet, width of water surface divided by 5. So that's our setup there. So we're going to go 25 raised to the third. That equals 15,625. We're going to divide that by 5. 3,125. And then we're going to multiply that times 32.2. Okay, so that's a pretty large number, but that's going to be taking the square root of, because Q is squared. So really we get 317.2114. I'm just going to stick with 317 for now. So that is our flow rate. So if we take our specific energy equation, we're going to use this second version over here. We're assuming that the kinetic energy factor is 1.0, so we're going to ignore alpha for now. So we have 317 squared divided by 2G, so 2 times 32.2 times A squared, which was given as 25. So that is the setup for that portion of the equation. That equals 2.4966. So if we go with 2.5 plus, then we need to know Y, depth of flow. Well, given that the area, the width was 5 and the area was 25, we can determine that the depth of flow was 5. So 2.5 plus 5 equals 7.5. It looks like the answer is C for this case. So the specific energy of the stream would be 7.5 given the material that we were provided. So we did was we used the critical depth equation to find the flow rate first, given the information. Then we plug that into this specific energy equation. I guess you could also find velocity if you'd like, but this is both the same equation, just in different forms. And we use that to find the specific energy. So if you have any questions about that problem, leave it in a comment down below. Or if you have any suggestions for problems you'd like us to solve, you can also leave that in a comment. Anyways, we'll see you guys next time.